Once upon a time, 1944 to be exact, there was a machine that was 51 feet long, 8 feet tall, and 2 feet deep. Its metal relays were clinking and clattering and clanging noisily away, churning on a problem. When the problem was finished and the solution was typed out on the electronic typewriter output, the answer was yes, implosion is a viable option to detonate the nuclear bomb that was used over Hiroshima, thus ending the war sooner than it would have been and saving possibly millions of American lives. The machine solved this problem. I don't know how long it took it, but this was the Mark I machine at Harvard, one of the earliest computers working with mechanical relays, opening and closing. Closed meant a 1 binary, open meant 0. It could do 3 additions or subtractions in 1 second, or 1 multiplication took 6 seconds. Trigonometric functions took somewhat longer, and this thing was performing differential equations, so I don't know how long this problem took. But the machine faithfully served the country by allowing us to save many American lives. This was a brainchild of Howard Aiken at Harvard, a mathematician and physicist who conceived of this computer in 1937 using the basic principles of Charles Babbage's analytical engine that he conceived in the 1800s. It used machine language, which is just the opening and closing of the relays, zeros and ones. This language is very unwieldy for us today, but then the engineers who built the machine were the only programmers actually. So in 1944, this machine solved that problem, and using machine language. Most computers, or all computers up until about 1950, used machine language or something called assembly language, which developed very quickly to save programmers the unwieldiness of writing down zeros and ones. Assembly language consisted of mnemonics such as MOV, MUL for multiply, MOV for move. For example, MOV 4, AX meant to move the number 4 into the AX register, so in the CPU, so you're very close to the machine. This first true high-level language did not come about until Backus brought about Fortran in 1954. Fortran has been very successful and is still used today. By the end of the 1950s, there's a trinity of high-level languages: Fortran, COBOL, and ALGOL. Fortran was good for scientific problems, COBOL was good for business problems, and ALGOL was for computer people. ALGOL does not exist today. Fortran and COBOL do. But ALGOL spawned a language called Pascal, which was a very good teaching tool in the 80s. I learned with that one. It's structured language, which means you write procedures and functions, and in separate files. You don't write one big long spaghetti program. You have functions and procedures written in separately compiled files, so you can test them in pieces and find out if anything's wrong with each piece before you put the whole thing together. It's much easier to debug a program that way. Speaking of the word debug, this was spawned, or not conceived, it was a remarkable woman named Grace Hopper, who was one of the co-founders of the language COBOL. She had worked on that Mark I computer that I talked about earlier. This woman was, as I said, remarkable. She got a PhD in mathematics in 1934 from Yale, when very few women at that time had ever done this. She was a rear admiral in the Army when she retired. I think I'm going to show a picture of President Reagan promoting her to Rear Admiral. I'm glad I did this subject because I'm very interested in this woman now in her life. I found a video on YouTube also that if any of you are interested in. She was interviewed by David Letterman on his show, and it shows what a remarkable, I keep using that word, but it's true, a wonderful woman, very humorous. There's a video of her on David Letterman. If you search in YouTube for Grace Hopper, David Letterman, if you want to watch it, it's a short video of her interview with him. It's wonderful. Anyway, she also taught classes, as you'll see in one of my slides. You can see her teaching a class of military men. Most of the time when you see her, this is an older woman in her naval uniform, but she was a very beautiful young woman when she showed up at Howard Aiken's doorstep to work on the Mark I. You saw this frail little woman, but you can't judge a book by its cover because she soon had all the men's respect there. Grace Murray Hopper. So, as I said, there was a trinity of high-level languages by the end of the 1950s. Fortran, COBOL, ALGOL, and Pascal developed in the late 60s and early 70s. I hope this time is, this is a very short speech here, so I might not have all the timelines correct. Please forgive me. But Pascal came about from ALGOL, and then we developed into C language, and then C++. A whole operating system called Unix was written in C, and then something developed called object-oriented programming, which C++ implemented. That meant that you didn't have to program. Every time you wanted to describe a car, you didn't have to program it all new again. The object would be a car, and if you wanted a new model, you would just put in different parameters. We had C++, C#, and then as the internet and websites became more prevalent, we have languages such as PHP and JavaScript, which are very popular today, which allow websites to be dynamic. PHP and JavaScript running on the server side, and they can send new information back to the web page so they can make it more interesting and interactive. This is a very, very short runaround about programming languages, I know. The future of programming languages. I'd like to mention something called the Turing test. That means that test consists of putting a person in one room and telling them to communicate, have a conversation with somebody or a computer, they don't know which, in the next room. And to pass the Turing test, the person would have to not be able to tell whether it was speaking with a computer or a human being in the other room. Imagine the code that would be needed to write, to run through a machine. It amazes me to bring this about of artificial intelligence about. There's a wonderful movie, fascinating movie called Ex Machina that shows this very, very well and interesting. If you want to watch the movie, if you haven't seen it yet, it's very good. People in IT would probably really like it, all of you. It's EX space MACHINA, Ex Machina. It looks like Ex Machina, but I recommend this movie. In the future, they're working now, you've probably heard, all of you have probably heard that they're working on quantum computers. So instead of having a 0 or a 1 distinctly, each bit could either be a 0 or a 1 at the same time, which I can't wrap my mind around. And I wonder
how that will affect programming languages. I can't even imagine, but I look forward to. I hope I live long enough to see these computers brought about. Well, I know this was probably a somewhat disorganized speech, and I'm a little nervous. Forgive the hat; it's my security blanket. I'm very neurotic about it, actually. At least I hope I haven't bored you. Please look up Grace Hopper. I'm sure you'll find her fascinating. Thank you very much. Bye now.